Hello, and welcome to this presentation, Getting Started with the RTB2000 Basic Operation. In this presentation, we'll explain the basic settings used when making measurements with the Rohde and Schwarz RTB2000 series oscilloscope. This presentation assumes a basic understanding of oscilloscopes and how to operate them. If you don't have any experience with oscilloscopes, or if you'd like a brief refresher, you might want to watch the presentation Understanding Basic Oscilloscope Operation before beginning this presentation. Before we begin configuring our scope and making measurements, there are two very important front panel keys that you need to be familiar with: Preset and Autoset. Preset is used to return the scope to its default settings. This is very helpful if you're unsure about what the current settings are. Although Preset resets almost all of the settings, it doesn't erase any data you have stored on the RTB. Autoset, on the other hand, causes the scope to attempt to configure the vertical, horizontal, trigger, and display systems automatically, based on the current input signal. Although settings chosen by Autoset may not always be exactly what you need, they are very helpful in getting a waveform on the screen, and as a starting point for additional adjustment or tweaking of settings. Unlike Preset, Autoset leaves most other settings unchanged. One last note, be careful not to press Preset when you really want Autoset. The vertical system controls consist of the position knob and the volts per division or vertical scale knob. The position knob can be used to move the waveform up and down, and pushing the knob recenters the waveform. Volts per division is used to scale the waveform vertically. The current value of volts per division is shown at the bottom of the screen, and can of course also be read directly from the vertical axis. Recall that in most cases, we want to adjust volts per division such that our waveform almost fills the screen, since this maximizes the use of the bits in the scope's analog-to-digital converter. Having volts per division set too high not only means we're not using all of the bits of our ADC, it also makes it much harder to visualize a waveform or to accurately measure it. Just like the vertical system, the horizontal system has a position control knob that can be adjusted to move the waveform right or left on the screen. The horizontal scaling is controlled by the seconds per division, or horizontal scale knob. The current value of seconds per division is shown near the top of the screen, and can also be read off the horizontal axis. For the vertical system, the correct setting for volts per division is the one that maximizes the waveform vertically without clipping. But the choice of seconds per division depends on the application. We can choose larger values of seconds per division to see more cycles of a periodic waveform, and smaller values to see fewer cycles, or even just a portion of one cycle. Next, let's talk about triggering. Recall that there are many different types of triggering, but the most common and most basic form of triggering is something called edge triggering. In edge triggering, we configure a trigger level using the trigger level knob. Current trigger level is indicated by a TL flag on the right side of the screen, and is also shown numerically at the top of the screen. The trigger point, that is, where the trigger occurred in the displayed waveform, is marked as well. Note that an edge trigger can be defined either as a rising slope, a falling slope, or both. It's very important to set the correct trigger level when working with either periodic or non-periodic waveforms. The good news is that for many periodic waveforms, we don't have to be terribly precise in setting our trigger level. In this example, if we set our trigger level anywhere between plus 360 millivolts and minus 360 millivolts, we still get a proper trigger on this periodic waveform. However, if we were to set the trigger level too high, we might fail to get a stationary or stable waveform on the screen. Now let's look at the display system. Consider this rectangular or pulse waveform. If we wanted to know things like peak voltage, pulse width, or pulse repetition interval, we could of course look at volts per division, here 50 millivolts per division, and seconds per division, here 20 microseconds per division, and then start counting divisions and doing the math. Even with conveniently round numbers like the ones we have here, this is a time-consuming and error-prone process. Cursors are a significant improvement compared to counting divisions. By using two sets of cursors, vertical and horizontal, we can get results much more quickly and more precisely. We enable cursors using the cursor button and adjust them using the cursor knob, pushing the knob in to toggle between the different cursors. Values for each cursor and the difference between pairs of cursors can then be automatically read from the bottom of the screen. A further enhancement is the Quick Measure function, which automatically performs various common measurements of the signal and displays those measurements directly on the screen. For example, here we see automatic measurements for rise time and fall time, positive and negative peak, etc. On the RTB2000, there's also a measure menu which enables an enormous range of automated measurement types in 4 different categories. Up to 6 of these measurements can be selected and displayed at any one time, with the results being displayed both directly on the trace and in a table at the bottom of the screen. These types of automated measurements provide substantial improvements over manual or marker-based measurements. Let's summarize the main points. Basic oscilloscope operation involves the configuration of 4 systems: the vertical system, the horizontal system, the trigger system, and the display system. A good starting point for many scope measurements is preset and/or autoset, but be sure to remember the difference between them. Making good voltage versus time measurements is easier if you follow a few simple guidelines, such as setting volts per division to maximize the waveform on the screen, setting an appropriate trigger level to get a stable waveform, and using automated measurements whenever possible for both speed and accuracy. This concludes our presentation, Getting Started with the RTB2000 Basic Operation. If you'd like to learn more about the RTB2000 or about oscilloscopes in general, please see the links in the video description. Thanks for watching.